Okay, everybody done with the attendance? What are you guys doing? Reading my messages? No? Okay, so we are going through this topic, which is about traffic data collection and reduction, and why we need traffic data, what can we do with it, and the studies we apply, the methodologies we can apply for traffic data collection. There are 3 types, okay, and we have gone through the first one, which was doing it manually, okay, and manually does not mean that you will not have any device with you. Manual can also include some use of some devices, okay, but what makes it manual is those devices are handled manually, so you do not leave them on the road and the data is collected automatically, okay. So that is the difference between using devices in manual and in other type of studies. Got it? Okay. So in manual studies we basically talked about collection of 2 items of data. What was that? In manual methodologies, speed and volume, counting, okay. Moving on, now we'll discuss semi-automated studies, okay. So in semi-automated studies we use portable equipment, okay. Now what is the meaning of portable equipment? What is portable? You can carry, okay. So the instruments are short and lightweight, okay, and but they are not installed permanently. They are not installed permanently, okay. So you carry them with you, you put them on the side. Data collection is done automatically, okay. You need to be there just for the sake of putting the equipment and collecting it back, okay. So if I put it there for 2 hours, I don't need to be there for the data to be recorded, okay. So this is the main difference between this and the manual. And the third type, which we will discuss later on. The most commonly used portable equipment is a pneumatic road tube. I already showed you an image earlier on, okay. It's not so clear. It's just a thin tube, okay, which you may see across the road, even in Bahrain as well. So where is it? Somewhere, okay. So it's a very thin black tube, okay. They can be 2 at a point or 3 at a point, depending upon how much detailed data you need. There's a tube, okay, like a wire, and you put it on the road, and there's a counter on the side of the road, okay. And once the counting is done, you collect the tube, and that's it, okay. You can collect your count from the counter. So this is a most commonly used portable equipment, okay, and it can be used for counting, it can be used for speed measurement as well. In both cases you need to do some calculations yourself. You need to do some calibration yourself, okay. The tube basically counts axles, okay, the tires, okay. The tires are crossing over the tube, so the tube is basically counting those tires, how many times the tires have crossed the tube. This is what the tube is counting basically, okay. And using that you can calculate the count of vehicles, and you can calculate the speed as well, okay, because with the count is also giving the time as well. So the first set of tires at this time, second set of tires after 2 seconds, okay. So if it's a normal car, you can calculate the speed. And how do we do it for counting? I will just show it now, and we will use it later on as well. But if you want to convert the axle count into vehicle count, you need to do some calculations, and you need to do some manual counting as well, okay. You need to do some manual counting as well. So if you have a count from the pneumatic road tube, and that count will be the number of times the axles have crossed the tube. Axle means the tires, okay. So it will give you the axles, but to convert the axles to vehicles, I need to have some manual count as well, okay. Why? Let us see. So you put pneumatic road tube at a location for 24 hours. In 24 hours, the tube counted 11,250 times. Okay, now what is this 11,250? Number of axes, okay, number of times the tires have crossed. Clear? So if the tires have crossed 11,250 times, then how many vehicles have crossed? Divide by 2. Who said that? You. Yes, Padma, do you agree? Yes, why? The whole project is gone. Yes, divide by 2. Then something, right? He is asking twice, must be something, right? Yeah. Divide by 2 means what? Only cars, okay? Which is not true, right? We don't have only cars, okay? So this is why we need the manual count, to count or to know actually the average number of axles we should take per vehicle, because we know all vehicles do not have 2 axles. Got it? Yeah? Okay. So within these 24 hours, we selected a short time period to calculate this average number of axes. Okay? This is the count from that short time period. Okay? So now you can see this count is according to number of axes. Okay? So how many vehicles total I counted? Tell me. How many? Total vehicles in this count, the manual one. How many? Yes. Somebody said something? Yeah, this one. Count. Number of vehicles. Count. How much is it? 303. 303. Clear up till now? Okay. Now these 303s do not have 2 axes in all of them. Okay. So this is why we did the manual count. So manually we can see how many axes are there, right? Okay. So minimum number of axes 2. Maximum number of axes for this road 6. We can have more as well. Some roads have bigger trailers. Okay. We have seen the traffic which goes towards the port area, coming towards from the port area, or going towards causeway, you will see bigger trailers which have more than 6 axles. Okay, but in this case 6. Okay, so when you are counting manually, you counted the vehicle and you counted it against the number of axles it has. So if the vehicle was a small truck or a car, it had 2 axles, so you counted it here. If the truck has 3 axles, you counted it in this row. Got it? Clear or not? Okay. So I have in total counted 303 vehicles. Out of those, 2 axles were in these many, 3 axles were in these many, and so on. Okay. Now how many axles I have counted actually? How many axles in these 303 vehicles? Tell me. How many axles in these 303 vehicles? Huh? 6 axles? 6 is the maximum number. Right. So when you saw 303 vehicles passing from in front of you, how many axles have actually crossed you? This is what I'm asking. How many axles have crossed you in these 303 vehicles? Yes. Yes. Same, right? Multiply the number of vehicles with the number of axles it has. Okay. So 157 vehicles passed which had 2 axles, right? So this is the number of axles which passed me in these 157 vehicles. Okay, and the same. So 55 vehicles passed which had 3 axles. Okay, and so on. So how much total? 892. Any problem till now? I have number of axles, I have number of vehicles. I'm looking for axles per vehicle. What should I do? Divide what with what? Number of axles by vehicles. How much? Axis per vehicle, right? 2.94. Okay, so if you just assume that all vehicles have 2 axes, you will be wrong by this much. Okay, so now I know on average number of axes I have per vehicle and total number of axes I have. Okay, so how many vehicles? So vehicle in 24 hours. I will divide what with what? Yes. What am I dividing? I have average number of axes, I have total number of axes. I want number of vehicles total. What? Yes. So 11 to 50 divide by 2.94. Okay, so this will give you number of vehicles. Clear? Any questions? Yes. Clear? Okay. Like 10 minutes ago, right? Yes. Your face turned blue 10 minutes ago. That's what I'm saying. Yes. Yellow. Yellow is your national color.
From the time we got the total number of observed vehicles.
Number of vehicles from here.
Yeah.
This is for the manual count. Okay. Then I multiplied the number of axes with each number to get the total number of axes. Okay. Now I want what? Axes per vehicle. Axles per vehicle. Average number of axes per vehicle. Okay. So I have number of axes after multiplying, and I have number of vehicles. Axes per vehicle. Okay. Clear? Sure. Okay. It's a dangerous thing when Bahraini say inshallah. Clear or not?
Yes.
Okay. And then now you have total and you have average. Okay, and you want number of vehicles. So you have number of axes and you have axes per vehicle. I want number of vehicles. I have axes per vehicle. I want number of vehicles. Axes per vehicle. I divide them, I get number of vehicles. Okay. How much is this?
3827. Round up, right?
Doesn't matter. Yes, any problem.
Motorcycle to be 2 axles.
Sorry?
Motorcycle 2 axles.
Motorcycle. In the end, you want number of vehicles, right? 2 will be counted as 1 vehicle. This is what I want, right? Yes. Any problem? Any questions? Clear? Okay. So I told you can use at one location multiple setups of road tubes. The first setup which you see gives you the total count across all lanes, across both directions. Okay, the total count across all lanes, both directions. So you see only one tube. Look at the top. Only one tube going from one end of the road to the other end of the road. Okay, so it doesn't matter from which direction the car is or the vehicle is coming and in which lane it is. Doesn't matter. Okay. The second gives you what now? Tell me. Each direction, right? For each direction. Okay. The third one for each lane. Okay. But in this case, you have one more step of calculations because of the placement of the counter. If I want it for the second lane, I cannot put my counter at the end of the lane. It has to be the end of the road, right? The side of the road. So this tube is not actually taking one lane. It is actually taking 2 lanes. Okay. So you have to do the do this. Okay, so when you go for each lane and you have more than 2 lanes, then this thing can happen. If you have 2 lanes, maybe you can manage one at one side of the road, the other one at the median, if I have 2 lanes. Okay, provided that you have space to put the counter, because obviously you have to protect the counter as well. Okay, otherwise the counter will be damaged and it will cause accidents as well. The counter has to be away from the vehicles. Okay, maybe there is space, but it's not enough to put the counter. If you put it, then it will be too close. Okay, so you have to keep all these things in mind. Clear? Okay, but you increase the number of tubes. Basically the idea is, if you want more detailed count, you increase the number of tubes at a particular point. Okay, and as I mentioned earlier, that they use these tubes very often. Okay, nowadays they are doing intersection surveys where I forgot. Anyways, but they are using these tubes on many locations. Usually they do it before they start doing any maintenance work, construction work. Okay, so like they do the count of 2-3 days at that location to know how much traffic they will expect on other roads. Okay, so it's a normal pattern in Bahrain that whenever they start any construction work or maintenance work related to the roads, they do these temporary counts to know the most accurate and most current counting. So if it is on the road, they use the tubes. If it is on the intersection, then you will see some people who are sitting there on a chair, okay, with a paper and pen. You will see them. Okay, if you like look up from your mobile, you will see. Okay. Then we have the third type of studies, which is done with automated detectors, which are permanently installed. Okay, so this is the fully automated type now. We have the manual, we have the semi-automated with portable equipments, and now we have the fully automated, which is using permanent detectors. Permanent means you install them properly, and you don't have to take them off to get the count. Okay, you don't have to take them off to get the count. Okay, so again they are there on Bahrain roads as well, on many intersections especially. Okay, they are doing that. So these another name for these permanent detectors is automatic traffic counts, ATCs. Okay, and if they are doing it on the intersection, counting done. Okay, we'll talk about it later on, some other topic. But the permanent detectors, if they are installed at a particular location, the counts which you get from there are called as ATCs. Okay, automatic traffic counts. Okay, just to show that they are taken from a detector. Okay, so these detectors perform multiple operations because you are not supposed to take them off. Okay, so they have to, like normal the tube, for example. The tube does not transmit data. It doesn't have to. You will get the data once the counting is finished. You will get the counter itself, right? You bring the counter to your office, you download the data. Here, there is no chance. Okay, so these detectors, they run continuously throughout the year. They transmit the count to traffic center or control center, whatever you have. Okay, and in many cases they perform more than one operation. Okay, like they are counting as well as speed data collection, something like this. Okay, and what else? Yeah, they can be used for real-time traffic management as well. Yes, so I mentioned about traffic signals, right? There is not some of them, yes, some of them do at very major locations. They can be used for changing the signal timing according to the counts you have. Okay, so a count from one direction increases, the timing of that direction will increase. Okay, in some countries they use it for automatic speed variations and automatic messaging as well. So they have these electronic boards, and if the counter is giving you the information that there is traffic jam or something like this, then you see it on the board before you enter the road. Okay, and sometimes they change the speed limits. Yes.
Doesn't they use for the night signals the wire, copper wires in the farm?
Yeah, same. These are automatic counters, right? They are there installed on the road. By the way, those wires are mainly for speed, for the yellow time. They are mainly for the speed, to measure your speed. The main function, we will discuss them later on. They are called loop detectors. They are mainly for the speed. So they want to know at what speed you are approaching the signal, and they change the time of the signal according to your speed. Like little bit. They change the time a little bit. So don't think, oh, let me go at 200 kilometers per hour. Signal will change time for me. No. Yes.
The same as the Amazon.
Same as what?
The Amazon.
Yeah. That is in the dilemma zone. Okay. So these automatic detectors, they are permanently installed. They are used for transmitting the data real time, because you cannot take them off and download them. They perform multiple operations, give you multiple source of data, and they can be used for real-time traffic management. Okay, like traffic signals and change their speeds. Okay, there is a reference book available. Edition you can search, maybe there's a newer edition available. But the point is, a lot of research has been done in the field of these traffic detectors. Okay, and there are now tools and softwares available as well, which work with. Is it mentioned here? Yeah. Which work with regular video and images as well. So there are tools available. You can have a very regular video taken from your phone. Okay. Unless it's an iPhone, then it's not regular, obviously. Very high quality, right? So these tools and softwares can process the video and give you the counts. Okay. But obviously you cannot call them then automatic detectors, because you are taking the video and you have to process it and download it. There's no real time. So automatic detectors, they perform their operations real time. Data collection, traffic management, data transfer, it all happens in real time. It's not happening in real time, that is not the same thing. Okay. These detectors can be using different technologies. They can be using the noise variation of the vehicles when they are passing. They can be based on visual data, images, videos. Okay, so this is called as opacity. They can be using magnetic or other source of transmitted energy. So in that case, they are installed on the side of the road. Okay, you have done the course of surveying, right? Okay, so which instrument you are using in surveying? If I have to find out, for example, angle of something, which instrument did you use? Total registration. Okay, so total registration works on the same principle. You have an instrument and the other side is a reflector, right? Okay, and how do you get the distance? When the energy goes from the instrument to the reflector, it comes back. Same principle here. Okay, so you have the transmitter at one end, the reflector at the other end. Okay, like on both sides of the road. And when the car passes, vehicle passes, the interruption in the signals tell you the size of the vehicle, the type of the vehicle, and so on and so forth. Okay. So then we have the loop detectors, the wire, the copper wire which is on the. So they are under the road, okay, and then they are using the timing that car is taking between the two wires. So it's a loop, right? So they are called the loop detectors, and basically these two are on the side of the road, these two are under the road. Okay, so the name which is given for these, in fact all of these, the first four is the side radar. Okay, this one just looks like a camera. This is like a camera. Okay, but these two especially, they are called the side fire or the side radar, and these are called the point detectors, which are under the road. Okay, we use them for traffic data collection. So our main aim is what type of data it can give us and what is the accuracy of the instrument. Okay, but we do not obviously design them. Okay, and you know why? Because we don't know. As civil engineers. Okay, and then we have the VIP, which is what? What is VIP? Very important person, right? Me, myself, right? Okay. So VIP is for video image processing. Okay, so same concept, right? Very important person must have a video after every hour, right? It must be posted on Instagram. Okay, so video image processing is a automated process in which the video is collected and processed in real time, and the data is extracted then and there. Okay, so in some countries they already started using these video cameras, which are especially at the intersections, because using this video image processing, then it becomes easier to see where the vehicles are moving, in which direction, and from which lane. So on the intersection, it is more important, right? In which lanes the vehicles are going, and in which direction they are going. Okay, so video is considered more accurate way of knowing that. Okay, so in some countries they are already using it. So this is again an automated study, automated technique, because everything is happening real time. Okay, now to make it happen, you need some components, right? That's the whole process. So the process works on, obviously, video means you need a camera. The video has to be stored as well. Okay, it's happening real time, but the video has to be stored to be analyzed. Okay, so you need the storage device with the camera. Okay, then you need something to process the video, right? You need a software or a tool which can process the video. Okay, so you need that processor as well, and then you need the storage or the software which will extract the data from the video. Okay, so you need the camera which will capture the video, you need something to store the video, you need something to process the video, and then you need something to extract and store the data from the video. Got it? Okay, so there are these four components, starting from the video till the traffic data. Okay, but the concept is same. The video is processed, and from the video you are getting everything. Now, some of you have used videos for your projects as well. You have taken videos. Okay, so the project is cool, no problem. Okay, but when you are doing it for sake of this video image processing system, then you have to make sure the camera is at the right angle where it can capture the road without any distraction, without any obstruction. Okay, so it should not be like if a big truck is coming, then the car behind the truck is hidden from the camera. It should not be like this. Okay, it should be, you can do it for each direction, for each lane as well. Okay, the camera can, you can make a software which can process the vehicles of different directions and different lanes. You can, but it doesn't mean you have to. Okay, so you can use it for a smaller scope or a bigger scope. You can use it for one lane, or you can use it for the whole direction. Okay, and what else? Yeah, very important point here, because in your case, okay, or at least most of your cases, you were processing the video. Okay, you were doing the counting and everything. Okay, in this system, the processing is done by the software. Okay, so whenever you are doing that, you need to calibrate the software, because the software has to detect the vehicle from the video, right? The software has to detect the vehicle from the video, and the video is not showing only the vehicles. The video is also showing a bicyclist. The video is also showing a pedestrian. Okay, a board which is on the side of the road. Okay, maybe some construction equipment which is on the side of the road. Okay, so the video is showing all these things. Okay, so the software should be smart enough to extract the data which you need. Okay, so you have to train it. You have to calibrate it. Okay, that if you see something of this much or a set of these pixels, this is a vehicle. Okay, and if it is very small or very large, you can ignore it. It will not be a vehicle. Got it? Clear? So one type of calibration is that to detect the type of object. Okay. Another problem or another challenge with this image processing is the lighting. Okay, the lighting on the road is not always the same, right? Lighting is very important, right? So do this for us. Okay. So he will graduate and open a studio and something. I can give you an F, right? No problem. It doesn't matter. Okay. So what was I saying? Lighting, yes. So the video has to be calibrated in different lighting conditions as well. So once you install the system, you need two types of calibrations. Okay, before you start using the data from the system. Okay, you need to calibrate the system to detect the objects which you need, and you need to calibrate the system to detect it in different conditions of the road, the daytime, the nighttime, okay, with the street light. Okay, so in the morning, when it is early morning, there could be the lighting is not very bright, but the street lights are off. Same thing happens in the evening as well. Okay, so these are different lighting conditions: very bright, less brightness without a street light, very dark with a street light, and so on and so forth. Okay, so you have to train it, train the software, or you have to make some adjustments, so it can give you accurate count in all these cases. Okay, and still it is not 100% accurate. You have some margin of error. Okay, and when you have that margin of error, you should know about it. Okay, we cannot make 100% observation, right? We cannot make any observation 100% accurate and 100% error free. Okay, but the important thing is whatever the error is, you should know. Okay, so in the end you will make the adjustments in your calculations. Okay, so what is the best place to use this system? What place on the road? Intersections. Okay, straight counts are easy. You can do it with road tubes or other types of counters, straight moving vehicles. This direction, that direction, easier. On intersections, it's a bit more complicated. So those type of sensors and detectors usually do not work. Okay, I already mentioned when we are doing the you will see, so before they start the projects, for the roads, they do the counter using the tubes. For the intersection, they don't use the tubes. Okay, you will see it being done manually. Okay, and there's a link to the system which is working in US or some other country. Okay, you can have a look. But we are very busy, right? So obviously, we will not see. Okay, so these are some examples from both editions of the book. You can have a look at it. Okay, try to solve them. Okay, now we will discuss each or different types of traffic data items, how to collect them and how to analyze them. We start with spot speed studies, and this is what you have to do in your second submission of the, like before you do the progress presentation, this is what you need to have. So we are trying to cover the same outcome which we started in the last topic, how to analyze and collect traffic data. So a spot means a point. Okay, so if I am using any instrument to collect the speed, collecting the speed over a point is no problem. Okay, I'll point the instrument at the road and the instrument will measure the speed, no problem. Okay, but in some cases I don't have the device. Okay, so what do we do in those cases? How do we measure the speed without a device? How? What do we do? Stopwatch, right? So you need a distance, right? You need a distance. If you are taking a distance, it's no longer a spot. Okay, but that's a practical limitation. I'm doing it. I still want what? Spot speed. I still want spot speed, but my limitation is I don't have the device to measure the speed directly. So I'm forced to use the stopwatch, and to use the stopwatch I need a distance. Okay. So what they have said, if you have this practical limitation, and you want to measure spot speed, you can select a distance less than 1,000 feet. Okay. So if you remember, I was asking some of you how much distance you have taken for your speed in the first trial. This is the read. Okay. So some of you have taken hundreds of meters. Okay, then you cannot take it as spot speed. Okay, for spot speed, 1,000 feet is less than 300 meters, right?
3 or
3 or 5? How do you know? Okay, but less than 300 meters can qualify for a spot speed. Okay, so if you have the limitation of not having the device, limit your distance to less than 1,000 feet. Okay, more than that, it will not be called as spot speed data. So why do we do the spot speed analysis? To find out the choice of drivers regarding their speed. Okay, so if you are a driver, how do you decide about your speed? How do you decide about your speed? Like, I want an answer. Not this. Huh? I thought you said my mood. Huh? Road.
Also my
Yes. Maybe today I feel like dying, so.
not necessarily.
But sometimes, right? No? Never? Okay. Yes. So road conditions, right? And what else? Speed limit. Okay. The camera, right? There's the camera. Traffic. Okay. So road speed limit is also, or should also be an indicator of the road conditions. Okay. But the other thing is traffic. Okay. So you remember in the first chapter, in the first lecture, I showed you some graphs. Okay. And one part of the graph was called as stable flow. The other part was called as forced flow. Why did we call it the forced flow?
Because drivers don't choose their speed.
Drivers don't choose their speed. Okay. So if you want to know the choice of the driver according to the road conditions, you have to select the conditions which are free flow. Okay, because in those conditions he can select the speed based on the road conditions. If there's too much traffic, then the road conditions have little effect on the speed. Okay, other cars have more effect on the speed. So it's no longer the choice of the driver now. Got it? Clear or not? Okay, so for spot speed, one restriction is this one, the other restriction is the condition, the traffic condition of the road, not the design, the traffic condition of the road. And again, they have given us some values, okay, that you can do it under this limit, and these values are here. Okay, in most of the cases, if you have less than this value, less than this traffic on the road, it is considered as free flowing. Okay, so you will assume that if the driver is driving in this condition, his speed is basically his choice. Okay, but there are some major highways as well. Okay, like Sheikh Salman Highway, Sheikh Isa bin Salman Highway, the main highways. Okay, in those cases, because these highways are big, so even up to a flow of this much is considered free flow. Okay, because they have so many lanes and they have more width and they have high speed, design speed, and so on and so forth. Okay, clear? Okay, so if you want spot speed data, you have to follow these two restrictions. And why do we need spot speed data? To know the choice of the driver according to the road conditions. Once we get this choice data, where can we use it as traffic engineers? The first thing I already mentioned, which is the establishment of speed limits. Okay, the speed limit should be a representative of two things: road conditions. You know it as the engineer who is working on the road. You know what is the design speed of the road. And the second thing is expectation of the driver. Okay, or what he can practically achieve. on this road. So there is a road aspect and there is a driver aspect as well. So your speed limit should be considering both these things. Clear? Okay. So for example, the speed of the road is 120 km per hour, but the driver has just crossed the signal. 99% of the time, the speed will not be 120. Better point. Okay. So you have to consider both these things: what he can or what he is thinking to achieve, and what is the condition of the road. Okay. So this is where you need the spot speed data. When you are going for design of any element of the road, the number of lanes, the signal timing, the speed humps, okay, the gradient, okay. Again, your choice will be based on spot speed data. Same thing, okay. Investigation of high accident location, something which I mentioned in the last chapter as well. Speed is directly related to accidents, okay. High speed and high accidents, good. Chances are high, right? Because your reaction time will be lower at high speed, and severity, seriousness of the accident will also be higher. So if you are investigating a location which has high number of accidents or very serious accidents, you should consider the speed at which the drivers are going on this road. Okay. So in most of the cases, this is one of the main causes. Okay, and this is proven with data. Okay, we have data which shows that going over the speed limit is one of the main reasons of having the crashes in Bahrain, in Saudi, and wherever you people go. Okay, so we talked about loop detectors earlier, and I told you near the signal, it is installed near the signal, but the main operation of the loop detector is to find out the speed of the driver. Okay, so, and this is what it looks like. It's a set of wires. Okay, you cross from here, you cross from here, so you know the distance between. So it's basically distance upon time. Okay, and you have the speed guns, you have the radars, the speed cameras. Okay, these are the radars. They don't measure, by the way. We call them speed cameras. Okay, but they are just capturing the image. That's it. Like, they're not taking the video complete. Okay, the main function is speed measurement. Okay, and speed data. Once you collect the speed data, you have different values, right? These values are arranged in groups, and for each group, we try to find out the number of drivers who are driving within a limit. Okay, so speed data, when we are analyzing speed data, or the methods which we will discuss to analyze speed data in these slides, or which are applied in traffic engineering, these methods require you that once you have a speed data, you arrange them into groups, and for each group you will have a number of drivers which are in this limit, the limit of the group. Okay, something like this. Okay, or let me show something like this. So you have the groups and you have the number of drivers which are in this group. Okay, so this group is between this limit, and how many drivers are in this limit? 5. So we don't know we are not arranging them as per the exact value of the speed. We are arranging them how many drivers are in this group. Okay, because in the end this is what matters to us. Okay, we are trying to get away from the individual values because they can be very tricky because of some drivers. I already mentioned the last topic. Okay, some drivers could be going very fast, some of them could be going very slow, and this can disturb your data. So doing this sort of analysis is safer. Okay, it will have less disturbance in the data. Okay. Okay. This sheet is, if you decide, if you have a speed gun, a speed radar, something which can give you the speed directly. Okay, so you put it on the road, and the device shows you the speed directly, no distance upon time, speed. Okay, and second thing is you decide what will be your speed groups, which is very difficult to decide in advance because I don't know what the speeds I will get, right? Okay, but somehow if you have a radar and you select your speed groups, then you can set up your field measurement sheet in this way. Okay, so you have the groups, the range of the groups. Okay, so a radar shows me a value of 34.5. So I know 34.5 will be in this group. Okay, so I put a line here. Okay, and these lines are called as telemarks. Okay, so whenever we are counting, you will count for the other part of the project. Okay, when we are counting, we don't write numbers because that will take more time and the numbers increase in digits, right? So we don't do the counting with numbers, we do the counting with lines. Okay, and the notation is you count up till 4 lines. Okay, for the 5th one, then you put the cross. So 1, 2, 3, 4, 5. Then again 1, 2, 3, 4, 5. Okay, total how many? 10. Okay, so counting becomes easier. So this is the one thing which you did in the field, and this is the one which you will use in the end. Okay, now you have to make groups, right? So the size of the group, there are some guidelines given for it. Okay, the maximum size of the group, speed groups, can be 5 miles per hour, maximum. Okay, so between this value and this value, the maximum should not be more than 5. This is from the data which they have collected previously, and according to their observation, this is what is true. And that data is like a lot of data. It's not from one study. They collected data for one day and they said, no, we'll fix it. No. They have done it over many, many years before giving us these guidelines. So following them is good. So maximum is 5. So if I reduce the interval between the group, if I make it smaller, okay, what will happen to number of vehicles in that group? It will reduce, right? You will have very few values which are within a very small interval. Okay, so you have to now balance. Okay, if you make it too high, what will happen? The number of vehicles will increase, but what will happen to the whole data set? What will happen to the other groups?
You will not see the variation.
The other groups may start having zeros, because those 2 or 3 groups are having all the values. You make them too big. Okay, so 2 large groups. Okay, if you make them groups too large, you will have a lot of values. Okay, and if you and the other groups can become 0. So the rest of the data will be useless. Okay, and if you make them too small, you will have the other effect. Okay, you will have too many groups and so on and so forth. But it may happen that in some of the groups you have too many groups, you have values, maybe none of them, but all these values are 1, 2, 1, 2, 1, 2, something like this. Okay, so you have to balance. Later on, I will tell you a restriction for the number of groups. Later on, we will do the analysis. Okay, and I will show you why we are saying that. Okay, this is the speed data. Once you have collected the data, you have made the groups. Okay, however you want. You collected data using radar. You collected data using stopwatch. Okay, you decided the groups before taking the data. You decided the groups after taking the data. Whatever you did. Okay, this is what you will do in the end. You will have groups. In each group, you will have the frequency, the number of observations. Okay, which is represented with small n. Small n means the number of observations in each group. Each group has a range, and each range has a mid value. Okay, clear? Okay, who decided these values? You guys will decide. Okay, the person who is collecting the data. So these 3 columns are decided by you, but should be based upon data. As I told you, we don't need all values in 2 groups and the rest of the groups are empty. And we don't want all groups to have 1, 2, 1, 2 values. Okay, you need to balance. But in the end, you decided them. From where did I get these values? from the field. Okay, they are not fixed, they can be in any order, okay, any numbers, okay. And then we have the percentage of frequency in each group. Okay, so the total is this much. The first value is 0% obviously. 1.36% is what? 5 over the total percentage. Clear? Clear? Okay. Next one is cumulative frequency, cumulative percentage. What did we do? You add. Clear? Any problem till now? Clear? What else? Okay. What was small n? Number of observations. Capital S is the middle value of the group. Capital S is the middle value of the group. Clear? Okay. So this column is this into this. Okay. We will use it later on. We are not using it now. Just keep in mind. Okay. So this column is this into this. Okay. And this will be used to calculate the mean, the average speed. This column will be used to calculate the average or mean of the speed. Okay. And the last column is n into s square. What was s?
Speed.
Which is speed? Huh? Not middle. Middle. Mean is the mean. Okay, middle. Okay, so each group has a middle value, square of that value. Got it? Clear? And this last column will be used to calculate the standard deviation, variation in the data. Clear till now? Any problems? Okay. These two graphs help us calculate some parameters related to the speed data. Okay. What are these graphs? The first graph is between the middle speed and the frequency of each group. Middle speed, third column, x-axis. Percentage frequency, fifth column, y-axis. Got it? Okay. So this versus this, the first graph. Second one, top speed of the group and cumulative frequency on the y-axis. Second column, okay, and sixth column, okay. This versus this, clear? Okay. Okay. The one thing, you look at these values, you can see the greater than sign here. Okay. So this value must be greater than 30, right? This value must be greater than 30, and this value must be what? Huh? No, but the values which you are putting, they should be equal to 32 or less. Okay, less and equal to. So there is no inequality here. There's inequality here, right? No equal sign. But here, so if the value is exactly 32, it will go in the first group. Get my point? Okay. Going back to these graphs, you see the once we have plotted the points, so these points are what you see on the table, right? Okay, and then you can see that there is a curve which is going through these points. Okay, but especially if you look at the first one, you see that all points are not joined, right? All points are not joined. Okay, so this is what we call as a best fit curve. When you plot the points, you don't simply join them. Okay? If you join them, what will happen? Look here. Will you get an even shape if you join these 3 points? Okay? Your shape will be zigzag, up and down, irregular. Okay? So this is the reason we plot best fit curve. So we can see the trend of the data, the general trend of the data. Okay, so we are not focusing on each and every point. We are looking for the general trend of the data. And why? This will come later on. Okay, if you do it, obviously we do it using the softwares now. So the softwares have this option to do the best fit for you. Okay. In Excel, if you do it in Excel, it is called the trend line. You plot a graph, you go into the graph, insert a trend line. The trend line will be a best fit curve. So it will not join all the points, it will join, or it will give the line which is best passing through the point. But a regular line, a regular curve. Got it? Okay. So we have looked at the data. We have looked at the things which you can immediately calculate from the data. I showed you the last two columns here. Okay. They are for later calculations. Okay. I showed you these graphs. Again, they are used later to analyze the data. Okay. So the last two columns and the frequency and everything, they are for analyzing the data. So which statistics about the data are important for us? Okay, Mr. Statistics. Pay attention now. Okay. So we have two types of statistics for any data set. One is called as central tendency. One type is called as central tendency. The other type is called as dispersion. For any data set, we can have two types of statistics: central tendency and dispersion. Central tendency means where the center of the data is. Okay, the statistics, the values which represent the center of the data, like average. Okay, but average is only one type of center of the data. The other one is dispersion of the data. How far the data is going from the center. Dispersion is how far the data is going from the center. So center is one value, right? Center is one part of the data. But there are other parts of the data which are away from the center. So how far are they from the center? This is called as dispersion. Clear? Okay. So average, mean, okay, is which one? Central tendency or dispersion? Central tendency. Okay. Now remember, we have arranged the data into groups, and each group has values, right? So it is no longer simple average. You cannot take simple average. Simple average is what? Number of summation of values upon number, right? I don't have the values now. Values are merged into groups, right? So that average cannot be calculated now. Huh? It's like you make your life difficult yourself. This is what you did when you chose engineering, right? He is enjoying. No problem. Okay, so we group the data. So now we can no longer use the average. By the way, in your calculators, if you are not using the calculator from the phone, even they may have it, but in your regular calculators, okay, the cheap ones, they have the options to calculate the statistics for group data as well. Okay, that was shown to me by a student 2 years ago, or no, before that, when you were in ISA term. So you can use that. You can use the option. You will do it, and you will waste your time in the exam, and you will say, "Doctor, you gave us a very long question." So yeah, I know it's a long question, but you have the tool to do it quickly. Anyways, so if you want to calculate the mean of this data, remember we calculate this column, right? N into S, number of observations into the middle speed. This one. Okay? So the mean is summation of this column upon summation of this column, number of observations. Summation of N into S upon number of observations. This will give you the mean of the group data. Now keep in mind, whatever we are discussing is for the group data now, because we already grouped the data now. Clear? Okay. So normal observations, normal equations will not work. Clear? So what will be the mean here? Tell me. No, for sure. Yes, I can. What is this? iPhone? Somebody tell me from iPhone. Okay. How much was it?
This is the iPhone, guys. 48.9.
Okay. Clear? Any problem? Yes, any problem? I'm asking him and you are doing this and he is, huh?
He's asking how did you get to me?
How did we get the mean? Why are you asking him and doing this to me? Yes, any question? Okay. If you don't want to ask me, just say inshallah, I will understand. Okay. Then we have other measures of, like I said, mean is just one type of central tendency. Then we have other measures of central tendency as well, which are coming from the graphs. So now we come to the graphs. Why did we plot that, and what we can get from there? Okay. The next thing of central tendency we can get from the graph is median. What is a median? Huh? Central value. What did you say? Okay. Understand. Okay. The central value, right? Okay. Central value is at what percentage of the data? 50%. Okay. So we will use this graph. Now remember, this graph, upper limit of the group here, cumulative percentage here. Upper limit, cumulative percentage. What percentage I am looking for? 50. Percentage 50, not the value 50. Okay. Just to confuse you guys, you will see all the values are near 50 here. Median, mode, everything. Okay. But keep in mind, you have some other data. The value could be something else. It could be 20. It could be 100. Median. But the percentage is 50. So we come here 50. Go to the graph. This is my median. Clear? Okay. Then the next thing, any questions up till here? The next thing we can calculate from this data is mode. What is mode? Not mood, mode. Yes, most repeated number. Now, but we don't have value, right? So I cannot see the most repeated number, but I can see the number which has the most observations. The number which has the most observations. Where did I plot the observations? Percentage? This is cumulative. So I cannot use this one. I'll use this one. Okay. So where is the most? The top value, right? Is this the top value? No. This has the top number of observations. So it is top on the y-axis, not the top on the x-axis. I'm not looking for the highest value. I'm looking for the value with the highest number. Got it? Clear? So you look at the top of the graph and then you plot it here on the x-axis. This is your mode. Got it? Clear? Okay, you have to keep in mind, I'm looking for the values and I'm trying to find them out using the y-axis. Okay, so I'm not looking for a value of 50, I'm looking for a percentage of 50. I'm not looking for the highest value, I'm looking for the number which has, the value which has the highest number. Okay, so mode, and this is done. Then the last thing, the last measure of central tendency is the pace. Okay, pace is a range. Pace is not a value, it's a range. Okay, and the interval of this range is 10 in miles per hour. How much? 10. Okay, now where is this 10? You will go to the first graph. The concept is pace, the number of observations which you find in the data in this 10 miles per hour is comparatively higher than any other 10 mile per hour range. Got it? So your data starts from 30 and goes up to 60, let's say. So I can make a 10 mile per hour range from 30 to 30 to 40. 30 to 60. 30 to 40 is 1, right? Okay. Now we'll look at the number of observations I have in this one. Okay. Let's say there are 3. Now I shift. Let's say 31 to 41. Now how many I find here? If they are more than 3, then the last one cannot be my pace. Got my point? Okay. So if you keep on shifting and the values are increasing, that means the last one cannot be your pace. But you reach a point, if you move forward, the values decrease. If you move backward, the values decrease. Then this one is your pace. Okay, the one which can no longer be batted with. Okay, so what do we do? Again, we'll use the graph. Okay, the first one, you already did the mode, right? Already did the mode. Okay, so mode which has the highest number of factors, right? But it is one value which has the highest number. I'm looking for a range now. Okay, what is my range? 10. Okay, so what do we do? So what we are doing, we were starting from here, from the starting point, 30 to 40. Okay, I can count the number of values I have between 30 to 40 from the graph. Okay, but you can see they are not more, right? They are not the highest. I can look at the graph. So I go from here to here. Are these the highest number of values? No. So I should shift forward. Okay. I go 31 to 41. Do I get the highest number? No. I keep on shifting. You are getting the point? Huh? No. So 30 to 40, you have this much portion of the graph. Is this the highest portion? No. Why are you saying no? Okay. So we keep on shifting. Okay. Now you reach here. Now you see the blue lines here, right? The blue line is actually my pace. Okay, from here to here. Now if you see, if I move on this side, the graph starts going down. And if I move on this side, the graph starts going down. So within this, I have the peak. Okay, so I will stop here. Okay, because shifting on any direction will only reduce the values. Got it? Okay. Then I see the values which are within this. Okay. So when I stopped here, when I achieved the peak, okay, and shifting was no longer possible, I stop here and I see this value is how much, and this value is how much. This will become my pace range. For this data, the pace range is this much. So when I stop between 42.5 and 52.5, okay, shifting was no longer possible. If I shifted anywhere, it is only reducing the value. The graph was going downward. So you only have to focus on the graph, not the number of values. And you get the point why we are doing it on the graph. Because I don't have to count now. Okay, I just see. If I shift here, you see the graph is going down. If I shift here, you see the graph is going down. So I'll stop in the middle where the peak is in the middle. Simply said, the peak is in the middle. Okay, clear? And then you see what values I have achieved on the x-axis. This will become your pace. Clear? Clear? Okay. We stop here regarding the analysis. Just one point. You look at the graph. Okay, the first graph. What is the first value on the graph? The top value. The top graph, the first value. What is the starting point of the graph?
31.
Okay. What number? 0. Okay. What is the end value? Whatever, but the number is 0. Okay. You come here. Starting value, number is 0. Final value, the number is 100. Okay. Now this is very obvious because it's cumulative. The cumulative percentage can go up to 100, right? Okay. So the final is 100. but I want to talk about the 0. Okay, now you look at the table. Do I have any values in the first group? Can I say my speed data starts from 32, not 30? Can I say this? Huh? Or my speed data is more than 32. There is no value between 30 and 32. Can I say this? Okay. Same thing for the last group, right? My speed data ends at 66. I don't need this group. Got it? Clear? Okay. So if I remove this group and this group, I will not lose any values. Right or wrong? Okay. So these groups are additional for the sake of closing the graph. Okay. We made them. Okay.
So we'll add them or not?
We keep them for the graph analysis. We keep them. Obviously, in the mean and standard deviation, they will not have any effect. But for the graph, we keep them, because if you don't keep the 0 groups, your graph will start from where? Somewhere in the air. We don't want this. Okay. This is called as a closed end graph, or the closed shaped graph. This is what we want. Because what type of graph was it? Did I join all the points? No. I did what? Best fit. You cannot do best fit until you know the start and the end point. How will I make the shape if I don't know from where it is starting? Somebody will come and he will start from here. His best fit will be something else. Okay? And somebody will start from here. We don't want this. Okay? So for closing the graph, we add groups. Okay? Even if they have 0 values. Or they will have 0 values, obviously. They will have 0 values. Okay? And this is to make the best fit curve more accurate and closed. Clear? Any questions? Okay. Thank you. Go home. Not anywhere.